Hello, welcome to video 2 in this mean value theorem series. My name is Nakia. I'm happy to help you through this journey. I hope you enjoy it. We're going to introduce the mean value theorem and we're going to prove it. Here we go. Now, in the previous video, we looked at Rowe's theorem. It had 3 conditions. The mean value theorem erases one of those conditions. Okay, so your function f of x is going to be a function that is continuous on the closed interval a, b, differentiable on the open interval a, b, and that's it. No third condition that Rowe's theorem had where when you plugged in a, you got the same y value as if when you plugged in b. I'm going to take that out. So the conclusion of the mean value theorem says that somewhere in your interval a to b, there will be a value c such that the derivative will be equal to this formula f of b minus f of a over b minus a. That should look familiar. That's the line that you get by connecting the endpoint of your interval and your function. Okay, I like to write it this way though. Multiply both sides by b minus a quantity and have it all on one line. F prime of c times the quantity b minus a is equal to the difference between f of b and f of a in that order. All right. So it's a generalization of Rowe's theorem. Rowe's theorem had a third condition on there. We're taking that condition off. Okay. All right, great. Here's an example of the graph that could be associated with such a situation where I have this secant line that connects my 2 points somewhere. I don't know where. Somewhere I could be sure that my tangent line will have the same slope as my secant line. Maybe more than one place. The issue is that there'll be at least one place where the slope of the secant line will be equal to the slope of the tangent line, but we just don't know where, okay? And remember now, the slope of the secant line is your average rate of change, and the slope of the tangent line is your instantaneous rate of change. I like to use this for the example where you're on a turnpike and you pass by the toll booth and then you pass by the exit toll booth. There's a certain time that went by, and we can get your average speed based off of that, and then we can then see how that is in relation to the speed limit, and you could actually get a ticket. Some states give you tickets based on the mean value theorem. Your average rate of change, your average speed was 90 miles an hour when you started at toll booth A and ended at toll booth B. So I can't radar you and say that I caught you going 90 miles an hour, but your instantaneous, there had to be some instance, maybe it was the whole time, maybe you're on cruise control, but it had to be some instance where you were going 90 miles an hour, and that's enough to give you a ticket. All right, great. So let's see how we can begin to prove this statement. What we're going to do is basically use the Rowe's theorem. Okay, so now the secant line connects the point A f of a to the point B f of b. The slope of that line is change in y over change in x, f of b minus f of a over b minus a. Okay, so then what about this actual equation of the tangent line, secant line? You know, like point slope, like y minus y1 is m times quantity x minus x1. Well, that's what that is, all in symbols. You got your y minus your f of a is equal to the slope of your secant line times the quantity x minus a. Okay. You could use the other point, the b point as well. Okay. So now if you add the f of a over, you have what y equals. Okay, that's your secant line equation. All right, so here's what we're going to do. We are going to call this function y. We're going to call this g of x. And then create a new function, which is the difference between f and g, f minus g. Call that function h. Okay. So we have f of x minus g of x. So it's basically it's the difference between the two, the actual function f of x and the tangent, the secant line. So there's a gap there, right? And so that gap is going to be what h measures. See it in the picture in pink there. All right, great. So we're going to use Rowe's theorem on h of x. Remember Rowe's theorem, you got to show that you're continuous, that you're differentiable, and that when you plug in the endpoints, you'll get the same value out. Okay. Well, why is h continuous? Because f was continuous, and g is continuous as a line. It's continuous. And the difference between continuous functions is continuous. All right, great. Why is it differentiable? Well, f is differentiable, and g is differentiable. So the difference between them will be differentiable. All right, great. The third condition is the one where we got to do a little bit of work. When we plug in a to h, and when we plug in b to h, we got to get the same thing back out. Let's check that. So when we plug in a to h, I got it in red there. The a minus a will zero out the slope term. And then the f of a minus the f of a, they'll cancel. You know, when you plug an a in, you'll get a zero out. Okay, great. Now we need the same thing to be true about b, because we got to have h of a be equal to f of b to use Rowe's theorem. Same thing happens. B minus a's cancel out. The f of b minus f of a, everything cancels out. So we then have both of these, h of a and h of b, equal to the same value. Rowe's theorem doesn't necessarily have to have them, equal to 0. They can be any height, but as long as they're equal, Rowe's theorem guarantees that someplace your derivative will be equal to 0. So let's consider now your derivative. Okay. We got this difference here, and we have a constant slope there, f of b minus f of a. And then we have that constant value there, f of a. So when we go to take this derivative, what we're going to get is f prime of x, and then the slope of a line. This is a line there in the square bracket. Remember, g was the secant line. Slope of a line is just the m part, the f of b minus f of a over b minus a. So h prime of x is equal to that. And Rowe's theorem says it's equal to 0 somewhere. Well, if that somewhere was the value c, then we'd have our condition for the mean value theorem. That condition is that f prime of c is equal to f of b minus f of a all over b minus a. That was our desired result. We started with f, who was continuous and differentiable, and that was enough to prove that we can guarantee that there's some place where your secant line slope will equal your tangent line slope. All right, this video is getting too long. Sorry about that. I just wanted to make sure that I proved it for you. It's manageable proof. Hopefully you can follow that. It wouldn't be something I would ever ask in my class. If it was an honors level class, I would have you definitely proven it. But in the next video, we'll look at some examples. Thank you for watching. Please like and subscribe. Comment down below. I'll see you in the next video.